Okay, let's talk for a few minutes. We're going to wrap this unit up and move on. I'm sorry this has taken so long, but let's jump right to it. Special angles. Special angle relationships is something that's going to play a large part in not only the rest of the semester, but the rest of the year as we go into basically all of the other units. Knowing how angle relationships work and how they relate to one another and the general information that you can glean from these is going to be super duper important. So let me go ahead. Let's start talking about what special angle relationships are like. So if I have these two, we're going to pretend these are straight lines going through here. You have two sets of special angle pairs. Let's go ahead and take a look. These are called vertical angles. Vertical angles make a V shape. Sometimes people call them kissing V's. They make V shapes, and they are always, 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 always equal to each other. Vertical angles are these angles that are opposite each other when you have two lines that are going through each other, that are intersecting each other. So you could think of this as like two planes flying in the sky. One is going this direction, and the other one is going this direction, and you can see their contrails. Please ignore my awesome drawing skills. And they've got these contrails that cross each other. So you've got these two vertical angles, and you've got these two vertical angles. Now I'm using these arc marks, these congruency marks with purpose. These are vertical angles. When you see those arc marks, that means congruency. So it has a twin. So you see the first arc mark over here. This is a set of one. Now I've already used my one, so I'm going to use two arc marks for the red ones. And that denotes that these are indeed the same. So let's look at a better example of vertical pairs. If I have this line going this way, and this line going this way, now you can see that a couple of these are acute and a couple of these are definitely obtuse, right? So where are my obtuse ones? Obtuse means bigger than 90. These are my obtuse ones. They're super duper big, right? No matter how I draw these, they're the opposites. These opposites are always going to be the same. This is a vertical pair, and here's another vertical pair. See that? So, vertical pairs. Always congruent. And that's that equal sign with the little squiggle on top. This means congruent. And congruent, remember, means the same size and shape. So it has the same amount, but it's also the same shape. And that's going to be really critical when we start talking about triangles and other shapes. Great, so that's a vertical pair. So let's look at an example of what we do with vertical pairs. So let's say, for instance, I have two lines. Let's say that this measure is 42 degrees. So how big is x? Well, we know that if this side is 42 degrees, then this side must also be 42 degrees. Why? Because they're a vertical pair, and vertical pairs are always congruent, right? So there's another really important relationship that we can glean from this right away, and this is something that you'll get used to seeing. Check this out right here. This is a straight line. How many degrees does a straight line have? Well, it has 180, right? So if that has 180 degrees in it, then that means that this angle plus this angle is 180 degrees, right? Because combined they make a linear pair. They make a straight line, a linear pair. really super duper important because every time you see a linear pair, you know that those two angles are going to add up to be 180 degrees. Remember when we talked about angle addition? Here's where it comes in really handy. So, well, I'm going to label this y because we're going to find y. So 42 plus y equals 180. Hardest part is turning it from geometry into algebra. Now this is really nice because now we can just solve for y in one step, right? We're going to subtract 42 on both sides, and y equals, I'm doing this in my head, 138 degrees. Okay, great. So if that equals 138 degrees, then how much does z equal? Well, y and z are what? Well, they're vertical pairs again. So if you've got another vertical pair, if y is 138, then how much is z? Z is also 138. Why? Because they have to be the exact same because they're vertical pairs. Okay, go ahead and pause it, take a look at it, because I'm going to clear it, and we're going to kind of look at this again. So, supplementary or linear pairs, supplementary angles, also called linear pairs. Now they are not one and the same. Supplementary angles don't have to be adjacent. Remember that adjacent means next to each other. Linear pairs, the angles have to be adjacent because combined they make 180 degrees. But both linear pairs and supplementary angles always equal 180 degrees. Always, right? So if we're trying to find x, and this is 150 degrees, how much is x? Well, again, let's do some angle addition. So we know that the whole thing, this whole thing is 180, right? So let's add the parts to equal the whole. X plus 150 equals 180. Goodness, that's awful. Let me try that again. X plus 150 equals 180. And so we're going to subtract 150 from both sides, and we get x equals 30. So x is 30. And that's about as deep as we're going to get with these. Let's talk about some of the other special angle relationships. So adjacent, again. So let's say we have something like this. This we know is definitely not going to be 180 degrees, not just because it doesn't look like 180 degrees, but because there's a vertex here where they all meet and it's not one straight line, right? This is an angle, not a straight line. And so it's definitely not going to be 180 degrees. So if we have A and B, what kind of special angle relationship is this? Well, it's not a vertical pair, right? Because it doesn't deal with straight lines, opposite angles that are made from straight lines. It's not supplementary because you can tell that it's not a straight line. It doesn't make 180 degrees. It's not complementary, which we'll talk about in a minute, because it doesn't make a right angle. These are simply adjacent. It's kind of like living next door to somebody. They are adjacent. I can almost spell. Adjacent angles. They're right next to each other, and they share a common side. So if you live in an apartment complex, if B bangs on the wall, A will hear it because that's also his wall, right? So they are neighbors, and they live in adjacent units. They're touching each other, they share a wall. Okay, and then complementary really quick. Two angles that make 90 degrees, and you know it's 90 degrees because they have that right angle symbol right there. So let's say I've got, well, you could even say, incorporate a little bit more vocab. Let's say we have an angle bisector. It's a ray that cuts the thing in half, cuts the thing into two perfectly equal pieces. So we know that they're equal, so we can mark it as equal. See those little arc marks? They're back. Let's say that this side is 45 degrees, and this is x. And they say, well, find x. Well, that's easy. We can do that because we're going to add the parts to equal the whole. What's the whole? Well, the whole is the right angle. It's 90 degrees, right? And the parts are the 45 and the x. So we subtract 45 from both sides. And we end up with x equals 45. Now wait, you didn't even need to do all that work. Why? Well, because take a look at this again. If this black line here is a bisector, to bisect means to cut into two equal parts. So if this angle is the same as this angle, if 45 is the same as x, then how much is x? Well, it's 45. Why do we know that? Because it's bisected. They have to be the same because that's the definition of what it means to bisect something. So, hope that was useful. I'm going to go ahead and put the review up, but it's really a two-part review, so we're going to have to figure that out. But I'm sorry this journey has been so rough. Please bear with me, and we will make it through this together.